it. So you will recall that last lesson we practiced working out the gradient. And just to remind you how we did that, okay, if a line was going upwards, we basically would draw in a triangle underneath it. And let's say that length was 4 and that length was 3. To work out the gradient, we did the y step, which is the amount upwards, divided by the x step. So you would do 4 over 3. Okay, it's the amount up, it's the amount upwards, so that length divided by the amount across. So you then divide by the amount across. And we were finding that if the graph was going up left to right, then we would expect the gradient to be positive. And if the gradient was going down left to right, you'd expect the gradient to be negative. Now, this forms part of when we write down the equation of a straight line. When we write down the equation of a straight line, we get something like y equals 2x plus 3, for example. Okay, now the various components of that, the gradient that we were doing last lesson, that is the letter m. That is the number that goes in front of the x. So whenever we have to work out m, we're just going to be what you did for the last Hegarty. You're just going to work out the gradient and do the y step over the x step. Now, what is c? C is the number on the end. That is wherever the line crosses the y-axis. Now remember, the y-axis is this one going upwards. So if your line, for example, crossed at +3 here, then you would be +3 on the end. If it crossed down here at -2, then your gradient would be -2. So all we're going to have to do today is just set up the skeletal format of y equals mx plus c, work out m, work out c, and that's your equation of your line. So let's just practice some. These are the same slides we used in the lesson. So in your workings, you would write out y equals mx plus c. Exam technique, if I were you, I would start off by working out c. That's the easy one. That's just where the line crosses the y-axis. So on this occasion, it's crossing there at +2. So just go and pick up that easy mark. Okay. And then what we were doing last lesson, remember that was working out the gradient. So take a triangle of your choice. Get used to calling gradient m now. So we need to do the y step divided by the x step. So the height of the triangle, which is 2, divided by the length of the base of the triangle, which is 1, and 2 over 1 equals 2. So the equation of our line is going to be y equals 2x plus 2. So on this occasion, the gradient was +2, going up left to right, and it crossed the y-axis at +2. So this one here, what is the equation of that line? Y equals mx plus c should always be your first line of workings as you gather your thoughts. Pick up the easy mark. Where does it cross the y-axis? It crosses at +4. Okay, so our final answer is going to be y equals so many lots of x plus 4. Now, what is the gradient? What is the gradient? So we're going to have to work out the slope, the gradient. So it's the height of the triangle divided by the base of the triangle. That triangle has got a height of 4 and a base length of 2. 4 divided by 2 is 2. Is it going upwards? Yes, it is. So the gradient's going to be +2. So the equation of this line is y equals 2x plus 4. Now I'm just going to speed this up a bit. So have a quick look at that and see if you can decide what you think the answer is going to be. Well, the plus c, where does that line cross the y-axis? It crosses at +1. And what is the slope? Well, the height of that triangle is 1, that height there. The length of the base of that triangle is 4, so it's a quarter, 1/4. So the equation of this line is y equals a quarter x plus 1. Let's just finish these examples with one going downwards. So your thought process, where does the line cross the y-axis? That's crossing at +2. So it's going to be y equals something x plus 2. Now, what is the gradient of this slope? Pop in a triangle. What is the height of that triangle? It is 2. What is the base of the triangle? The length of the base of that triangle, it is 4. Now, 2/4 simplifies to 1/2. But have a care, that is going downwards, that line. It's going downwards, not upwards. So it's minus that number. So your final answer here is y equals minus a half x plus 2. Now, I'm going to want you to do Hegarty number 208, please. And let me just model a few of these, please. So here we go. So y equals mx plus c. That's crossing the y-axis at +3. Pop in your triangle of your choice. Height of 3, base of 3, 3 divided by 3 is 1. So y equals 1x plus 3, but we never say 1x, we just say x. So your final answer must be y equals x plus 3. So that's an example of question 1. Here's a question 3. Right, quite nice. They give you a number of options. So just be smart here. Y equals mx plus c is your thought process. Well, it's crossing at +3. So the number at the end must be a +3. Okay. Now be careful. When I say at the end, they can go and put these two the other way around. You know, they can go and write it as c plus mx if they want to be awkward. But when I say at the end, that the number that's on its own, the number that is not with the x's, is clearly a +3. So that could be A, can't be C, because that's crossing at -3. Could be B, and it could be D, because look, that is y equals 3 minus 2x. That's actually the same answer as B, just with those two terms swapped around. That is the same thing as y equals minus 2x plus 3. It's the same thing. They just swapped the first two terms around. So all of those three are possibilities. They've got the +3 on the end. Now, look at the slope. It's going upwards. What does that tell us about the gradient? It must be positive. That's positive. That is not positive. And that is not positive. Those gradients are negative, negative, and I mean that one we'd already rejected. So even before I work it out, the only answer this could be is answer A. But let's just go and work it out properly with sort of ignoring the answers at the bottom. Okay, we know the gradient, it crosses the y-axis at +3. Working out the triangle there, that's quite a tricky one to see. That's a height of 3, a base of 1.5. 3 over 1.5 is how many 1.5s go into 3? It's 2 lots. So that's how we can actually see that it had to be part A. Okay, so let's just try and just do this by elimination. Where does that line cross the y-axis? At -2. So that could be that one. It can't be that one. That's 3x plus 2. That must be wrong. Okay, that's got a +2 on the end. That must be wrong. That's got a +2. That must be wrong. Straight away, the only answer this could be is answer A. Okay, now if I wanted to go and show that the gradient is 3, I could do. I could go and take a triangle of my choice. Let's just make sure it's nice whole squares. I could have taken that triangle. That would have had a height of 6, a base of 2, 6 over 2 equals 3. So that had to be answer A. And then finally, let's just look at question 6. So again, just do it by elimination. It must have a -1 as the c component. Y equals mx plus c. So the number that's on its own, must be -1. So it can't be that. Can't be that. Can't be that. The only answer it could be is answer A. All right, and again, that makes sense. We've got a positive gradient, and yes, it is going up left to right, so that looks good. And again, if we wanted to actually prove that that number is a 3, draw in a rectangle, a triangle, excuse me, with just whole squares, 6 and a 2, 6 divided by 2 equals 3. So that's it, folks. So please can you go and give exercise, Hegarty exercise 208 your best shot, please. Good luck, everyone. Bye.